All right. Welcome to IACP at Lincoln. We're looking at the pre-quiz questions 1 through 4 in the motion graph section of the second unit. So I'm going to go through these questions for you. The key is already posted for you to look at, and I'm just going to explain the key. Let's start with number 1. Sally's standing still at position 0. So you can see here she starts at position 0. She walks to position 5, and it takes her 5 seconds to do that. You can see here, this is seconds 5. So from 0 second to 5 second, she's walking forward at 1 meters per second. And we can see that 5 meters in 5 seconds gives her 1 meter per second. She stands there at the 5 meter position. She stays there for a little while, so her velocity is 0 as she's staying there. And that's from 5 seconds to 8 seconds. So that's for 3 seconds she stands still. And then she comes back to position 2, which means she has to move 3 meters in a negative direction. So she's going to have a negative velocity here as she comes back. And it looks like it takes her 2 seconds to do that. So I think this is just slightly wrong. This should be negative 1.5 here because she's going to move a total of 3 meters in a negative direction. Let's see what we have here. Yeah, so this should be negative 3 meters in 2 seconds to give her a backwards velocity of negative 1.5. Okay, so a slight little mistake there on number 1 on the key. And let's look at the accelerations. So if we were going 1 meter per second and suddenly stop to 0 meters per second, we can see that the velocity goes down from 1 down to 0. And so that's indicative of a negative slope here on the velocity curve. And that means we have to have a downward acceleration for that moment. It's a very short period of time where Sally goes from walking to stopped. Okay, so it takes a very short period of time. Similarly, when she turns around and starts going the other direction, she's also going to have a negative acceleration. She's speeding up, but she's speeding up in a negative direction. She goes from 0 down to negative 1.5 meters per second. So that speeding up in a negative direction means that she has a negative acceleration. You can see here the slope of this is downward, the slope of this is downward. So that's why we have a negative acceleration, If you look back to the concavity on the position curve, you can see this is a downward facing curve like a frown. So that's a negative acceleration. Similarly here you have a downward facing curvature. So that's indicative of this negative acceleration on number 1. Number 2, we have a scuba diver. And they're already moving at 2 meters per second at the start of the problem. And they're on their way from the surface down to 6 meters of depth. Okay, and it takes a little while if you're going 2 meters per second to go 6 meters. We can figure out that it's going to have to take 3 seconds, isn't it? So if we look here, we're going to go from 0 to 3 seconds, where we have this velocity downwards of negative 2. So that's right here, our velocity of negative 2. We can see here we started at 0 and we ended at negative 6 on the position graph. Okay, then what happens here? It looks like we stop at the bottom and looks at a fish for 1 second. So we can see her staying at the bottom for a second and then starts coming back up again. Okay, on the way back up, we're moving slower. Looks like we're only rising at 1 meter per second. And so from negative 6 up to negative 3, that's 3 meters on the way up. So that's going to take another 3 seconds from time equals 4 to time equals 7 on the way back up till the rest stop. Scuba divers often have a rest stop on the way back up where they make sure the nitrogen levels in their body are down. This is such a short dive with just a few seconds. It's not even a scuba diver, probably just a snorkeler. Anyway, stops at a depth of 3 meters. So we'll say right here, stays at negative 3 meters. That's the depth. That's why we're calling it negative. And we stay here negative 3 meters for a total of 2 seconds. And then finally continues back to the surface fairly rapidly because those last 3 meters are covered in just 1 second. So that's going to be 3 meters per second to come back to the surface. So there's your position graph showing the profile of the dive. And then here you have the velocities of the diver going down, then standing still at the bottom, then coming back up for a while. then standing still halfway on the way back up, and then the last velocity coming to the top again. If we look at the changes in velocity, we see we have a positive change in velocity here and here. Okay, those are very, very positive accelerations, but for different reasons. Let's look at each one in turn. So here you have a -2 velocity. You're on your way down, and then you stop, and that's a positive acceleration because you were going downward, and then you had to stop, which means you had to accelerate upward in order to stop that negative velocity. So that's why that one's positive. This one's positive because you're not moving, and then suddenly you start moving upwards. So that takes a positive acceleration to get moving upwards. So that's why that acceleration is also positive. Again, you can see that upward curvature here, and the upward curvature here is another indicator that this acceleration is positive. Now, when we go from this upward velocity to stopping again, that meant that we had to have a force that was downwards. We had a velocity that went from a positive velocity down to 0, so that takes a negative acceleration. Stood still, so no acceleration, and then finally we had to get an acceleration because we weren't moving, and then suddenly we were moving 3 meters per second upward, so that takes a positive acceleration as well. Okay, so that's number 1 and 2. And realize I just noticed we had this little glitch here, so we'll make sure that says 1.5 meters per second on the key. So thanks a lot, and I hope that helped you. And I'll put on the videos for number 3 and 4 in just a moment. Thanks.